Okay. Now, what's equation for speed of longitudinal wave? Root of bulk modulus by density. So we derive speed of longitudinal wave as root of bulk modulus by density. This was the formula which we derived as the speed of a longitudinal wave. So what about the speed of a sound wave? If sound wave longitudinal or transverse? Sound wave is what? Longitudinal. Sound wave is longitudinal in nature. Okay, so this is the expression for equation of a sound wave as well. Now, Newton gave an explanation for this. Newton gave an explanation for this, and Newton gave an equation for speed of sound wave. And there is another scientist called Laplace. Have you heard of Laplace transform in maths? It's a mathematical operation. So there is another scientist called Laplace who gave some correction for those Newton's formula. So that is Laplace correction. That is coming under Laplace correction. So basically we will be studying two topics. Newton's formula for speed of sound wave as well as its Laplace correction. That Laplace correction is very important. Okay. So, so we'll write, okay. So give heading.
You said you'll explain that question from our exam, right?
What is it?
The couple question. Translational motion from our exam.
Translational motion. For your exam. I will explain. I'll explain. Just remind me after class, okay? I'll explain it to Sunday students. The actual answer was A.
Isn't B?
You wrote B?
Yeah.
Went wrong, right?
Yeah.
I'll explain. Okay.
The question is rotational motion, right? Yeah.
I'll explain.
I saw couple as a rotational like
Okay. So give heading speed of sound in gas. That's the main heading. Okay. So we wrote the headings like speed of transverse wave, speed of longitudinal wave we wrote. Now next is speed of sound in gas. Speed of sound in gas. That is the heading. Speed of sound in gas. So Newton's explanation first we will write, okay. Now in this topic, you will come across few terms like isothermal process, adiabatic process. You studied in chemistry? Who all studied thermodynamics and chemistry? You studied. So you
studied
in school?
not in school.
Okay. So what is isothermal? It's a process in which temperature remains as a constant. Isochoric? Volume remains constant. Isobaric? Pressure remains constant. Adiabatic?
No heat exchange.
No heat exchange. There is change in temperature. There is no heat exchange. So different processes are there that we will study when we study thermodynamics. This chapter is supposed to come after that, right? That's why. Okay, so I won't be giving any explanation for that. We will study it anyway. So right, according to Newton, the propagation of sound through gas according to Newton, propagation of sound through gas according to Newton, propagation of sound through gas is an isothermal process. Is an isothermal process. For a gas, V is bulk modulus, which is equal to pressure P. For gas, bulk modulus is equal to pressure P. This we will derive, okay? This proof is there. Bulk modulus is equal to pressure P. No. So this is the proof for that. This, okay? See, for isothermal process, the equation is P, pressure into volume is a constant. That's the equation that we will study later in thermodynamics. In chemistry also we will study. For isothermal process, equation for isothermal process. Equation for isothermal process. P into V is a constant. P into V is a constant. Now, how will you differentiate U into V? Differential of U into V, max students. Differential of U into V.
V into differential of U.
U into differential of V, first into differential of second, plus second into differential of first. That is the formula. Okay, so here first means U into differential of second, plus V into differential of first. That is the formula. Okay, U into V. If you want to differentiate, first means U into differential of second means dV by dt, plus second is V into differential of first means du by dt. That's the formula. Okay, so you will be applying that. You will be differentiating this. Okay, differentiating. What you will get first into P into. Instead of differential of V, I can write delta V. Differential in delta is the same. So differential of me means delta V plus second into differential of P means delta P is equal to what is differential of a constant? 0. I'll take V delta P to the other side. P delta V is equal to V delta P negative. Now P is equal to, I need P. I need to find P is B. That is our A. We need to prove P is equal to B. That is our A. So P is equal to minus delta P V by delta V. This V I can take to the denominator minus delta P by delta V by V. What is this? Pressure by volume strain. Pressure by volume strain. What is pressure by volume strain? What is pressure by volume strain? Bulk modulus. Stress by strain. Modulus. Which modulus it is? Bulk modulus. Sodium, right? So this is bulk modulus. So you will get P is equal to B. That is the proof for this. Okay. Now, P is equal to B. All of you got right? Now listen. What does the velocity formula we know? What is for sound wave? That is longitudinal. This one we did last class. For longitudinal wave. What is the velocity equation? Give me the equation. Root of B by rho. Here we got B is equal to P. Correct. As per Newton, we got B is equal to P. So what I can write? Therefore, V will be equal to root of P by rho. This is the equation given by Newton. Newton's equation. It's there. It is like that. In the modulus, there is a negative. This is bulk modulus. Okay. Understood. Okay. Take down. And it's okay now.
Okay, very good, but I'm right.
Huh?
So when it's a new topic, I'm
This is not
after. There's nothing to see. Where it happened? That was a red marker.
Okay, copy this, then I will explain it again, okay? You know, yes, I like. All of you finished? Persin finish, Persin. I'll explain, okay? I'll explain. Once you finish, I'll explain it again. Finished, right? All of you finished? Panel finished? Okay, so in this topic we are studying, finished it all of you? Aligra finished. Okay, in this topic what we are studying is we are going to derive an expression for speed of sound wave. Okay, what was the explanation given by Newton? That is what we are studying. Okay, so we already studied last class that velocity of a sound wave or a longitudinal wave. Sound waves are longitudinal waves. Okay, velocity for longitudinal wave is root of b by rho. And what Newton said was that b is equal to p. So if you know the pressure and density, when you do pressure by density, you will get the velocity of a sound wave. That is what Newton said. Okay, so that is Newton's explanation. Now, how b is equal to p, that is the derivation which we just did. Okay, for that, Newton assumed that if a sound wave, propagation of sound through gas is an isothermal process. That is what Newton said. For an isothermal process, PV is a constant. That's the equation for isothermal process. For an isothermal process, equation for isothermal process is PV is equal to a constant. Now, when you differentiate it on both sides, P delta V plus V delta P is equal to 0, taking this to this side, you need to find what is P. From the equation, you will find what is pressure and you will get it to be B. So, in the basic formula, you will just substitute B as P. That's it. Okay, this is Newton's explanation for speed of sound in gas. Clear? This is okay. Now, another scientist called Laplace explained that this is not an isothermal process, but it is an adiabatic process. Okay, and we call it as Laplace correction. That is very, very important. Very important 2-mark or 3-mark question. Laplace correction they used to ask. So if they ask Laplace correction, you have to explain. Laplace explained, as per Newton, the process was isothermal. But Laplace explained that this process is not isothermal, but it is adiabatic. And then you have to do the derivation. Understood? So give side heading Laplace correction. The same formula, he made a correction. That's it. Okay. To the same formula, he made a correction. So give heading Laplace correction.
Longitudinal wave look like?
Longitudinal wave. See, so sound wave compressions and rarefactions. Remembering, last class we explained, right?
Yeah.
Understood? Jana?
Yeah. But then how will that work?
How will that work in the sense what you're asking?
No, like how will like in the transverse wave you drew and showed it in the like it's perpendicular way, right?
Huh?
So
Huh.
like that, how will longitudinal wave looks like?
Okay. See, for longitudinal wave, when you say something, here the air will vibrate. It is vibrating, and that vibration will be transferred to the next set. It is going like this. The vibrations are getting transferred. Okay, that is how it travels. See, if we are talking something, the air molecules near to your mouth will vibrate. Those vibrations will be passed on to the next set of molecules, and that is how it propagates. So it is in the direction. The propagation and the displacement is in the same direction.
Oh,
Understood?
yeah.
Okay. Now, give side heading Laplace correction. This is very, very important. Laplace correction. Laplace correction. Laplace pointed out that propagation of sound wave Laplace pointed out that propagation of sound wave Laplace pointed out that propagation of sound wave through a gas is not isothermal is not isothermal but is an adiabatic process adiabatic process. Underline adiabatic. Laplace pointed out that the propagation of sound through a gas is not isothermal but an adiabatic process. Yeah, right. For adiabatic process, PV raised to gamma is a constant. For adiabatic process, PV raised to gamma is a constant. That is the equation for adiabatic. You will study in thermodynamics chapter, okay? Later you will study. For adiabatic process, PV raised to gamma is a constant. Now we are going to differentiate. I'll explain the differentiation, okay? First into differential of second. So what will be that? N into x raised to n minus 1. That is how you will differentiate. So gamma into P into gamma into V raised to gamma minus 1 delta V. First into differential of second. Okay. Plus second into V raised to gamma into differential of first and differential of constant is 0. Understood? Okay, so this is how you will differentiate that. Now, from here you need P, right? So take this to this side, then everything else to the denominator. You have to find what is P. Okay, so in that formula, it was root of, yes, yes, yes.
Why we writing delta V?
See, if it is x raised to n, what you are doing? N into x raised to n minus 1. That is why how you are doing.
Yeah.
Okay, but anything else can be also there. It is not just x, it can be x raised to n into a, it can be.
Oh.
Okay, it can be anything. So what you will do? N into x raised to n minus 1, dA by dx will be there.
Yeah.
So whatever that term, you have to differentiate that. That's why.
Mm.
Okay, this is general formula, right? That's why.
Okay.
Okay, understood. So now find P from this equation. Find P. So P gamma V raised to gamma minus 1 delta V is equal to minus delta P V raised to gamma. So you keep gamma P here, okay? Rest all you have to take to the other side. Gamma P is equal to minus delta P V gamma by delta V gamma minus 1. What is V gamma by V gamma minus 1? VQ by V square is V will come in the numerator, right? So V will come in the numerator. Understood? So this is V. See, V cube and V square. V will come in the numerator. So here V gamma and V gamma minus 1. So V will come in the numerator. Correct, right? So this will be minus delta P V by delta V. Now this V goes to the denominator. So this will become minus delta P delta V by V. What is this? Bulk modulus. So here you will get bulk modulus is equal to gamma P. Here we will get bulk modulus is equal to gamma P. So therefore B is equal to gamma P. So therefore velocity is equal to root of gamma P by rho. This is the Laplace correction formula. This is Laplace correction. Very important. They used to ask Laplace correction. See, all these terms, there is gamma is the ratio of specific heat capacity. What is specific heat capacity? Everything is coming under thermodynamics. Okay. Now you just write this. Okay. You will understand what is gamma, what all are these equations are not when we study thermodynamics.
Laplace is like
Laplace is a scientist.
what we should find.
Okay. Newton explained that velocity is equal to root of P by rho. But Laplace made a correction in that equation saying that that process was not isothermal but adiabatic. That was the correction made by Laplace. That's it. Okay. So they will ask what is Laplace correction. That's it. Explain Laplace correction. That is how they will be asking. 2 or 3 they can ask. Laplace correction is very important. Finished, right? Okay, finished, right?
Gamma to minus in
Gamma.
minus in the
What is gamma?
and but there's other
I don't know. What is the other symbol for gamma?
it looks like arts. Gamma.
This is gamma, right? What other symbol you have for gamma? Finished, right? All of you finished? Okay, Laplace correction important. Okay, noted. That topic is over. Next, we will start with superposition of waves. Next, give heading Principle of superposition of waves. Okay, one more point. Just add the experimentally found value for velocity is velocity of sound is found to be 331.3 meter per second. Velocity of sound in air at STP. What is STP? Standard temperature and pressure. Velocity of sound in air at STP. Velocity of sound to air at STP is found to be this. 331.3 meter per second. Finished, right? Okay. Next you write principle of superposition of waves. Principle of superposition of waves. Principle of superposition of waves. Listen, okay? Listen. So you have two waves like this. One wave, another wave. So this is 5, amplitude is 5, this one amplitude is 6. When they both meet, what will happen? They will get added. Two waves are in the same direction. The resultant wave will be the addition of these two. So the resultant wave will have an amplitude of 11. The same type wave, but the amplitude will be 11. Understood? Understood. This is superposition. Another case, a wave, amplitude 2, another wave, amplitude 5. What will happen? They will subtract and the resultant wave will have an amplitude of 3. Because this 5 is more. The negative wave is more. So the resultant wave will be in the negative direction. So this is superposition. Okay. So when they both add, minus 5 and plus 2 add, what you will get? Minus 3. That's why minus 3. This is principle of superposition. Okay. So right, superposition principle states that superposition principle states that when a number of waves meet at a particular point,
Can you repeat?
when a number of waves meet at a particular point in a medium, when a number of waves meet at a particular point in a medium when a number of waves meet at a particular point in a medium, each wave produces its own displacement each wave produces its own displacement. Each wave produces its own displacement. Yeah, Sahil wrote. Each wave produces its own displacement. Yeah. Each wave produces its own displacement.
Yeah.
Independent of other. Independent of other. Independent of other. Independent of other. And the total displacement. And the total displacement. And the total displacement. And the total displacement is the algebraic sum of total displacement is the algebraic sum of displacement due to individual waves. And the total displacement is the algebraic sum of displacement due to individual waves. Finished? Finished, all of you? Finished, right? I'll read it again. When a number of waves meet at a particular point in a medium, each wave produces its own displacement independent of the other. So each wave has its own displacement independent of the other. And the total displacement is the algebraic sum of displacement due to individual waves. Okay. See, this is applicable not just for sound wave. In all waves, this is applicable. Next year, you will be studying this for light wave. Okay. So, basically, you have two torches. With one torch, you will have some intensity of light. When you are keeping two torch ons in the same direction, the intensity will be more. That is the concept. Understood? Okay. So, the equation form, in the equation form, you can write. So, y will be the resultant, y will be equal to y1 plus y2 plus y3, etc. So, y1 and y2 are the independent waves. Y is the net displacement. Clear? Write the equation also. Then we have a derivation for this. Finish? Finish. So, derivation. Consider two harmonic waves. Consider two harmonic waves. Consider two harmonic waves on a stretched string. Consider two harmonic waves on a stretched string. Consider two harmonic waves on a stretched string having same frequency and the same amplitude. Consider two harmonic waves on a stretched string having same frequency and same amplitude. Having same frequency and same amplitude, but with different initial phase. But with different initial phase. Same frequency and same amplitude, but with different initial phase. Let the waves are traveling. Let the waves are traveling. Let the waves are traveling in positive x-axis direction. Let the waves are traveling in positive x-axis direction. So the first wave, y1. y1 is equal to a sine kx minus omega t. That is a formula which we studied for waves, right? Plus phi is also there. So both waves, there is a phase difference of 5. So second wave, we will put plus 5. So the phase difference between them is 5. Clear? So first wave is this. The second wave, y2 will be equal to a sine kx minus omega t plus 5. What does that mean? Two waves are there. Their phase difference is 5. Correct. Okay. Now, what is superposition addition of these two? So we will add these two. Y will be equal to y1 plus y2, that is a, I'll take outside, sine kx minus omega t plus sine kx minus omega t plus 5. What is sine a plus sine b? Sine a plus sine b?
Sine B plus cos B.
No. That is sine a plus b. This is sine a plus sine b.
Sine A plus B by 2.
2 sine a plus b
minus
by
B
2
by
cos a minus b by 2. Okay. Sine a plus b is 2 sine a plus b by 2 cos a minus b by 2. So you'll apply that formula here. So a into 2 sine a plus b by 2 kx plus kx 2 kx. Okay. By 2 will come, so it will be just kx minus omega t plus minus omega t minus 2 omega t by 2 will come, so minus omega t plus 5 by 2 sin a plus b by 2 cos a minus b by 2 kx minus kx 0 minus omega t minus minus omega t 0
And whole by 2.
whole by 2 is there. For kx and omega t, the 2 will cancel. Cos minus 5 by 2. If you have doubt, you add one more step, okay? See, before this, you can add one more step. That is actually kx plus kx is 2kx plus 2 omega t plus 5 by 2. Minus 1. So when you add this, you will get this. When you subtract a minus b, when you do, kx minus kx 0 minus 0 minus 5 by 2 will come. That is how you are getting this. This is a plus b and this is a minus b. Understood, all of you? What I did? Okay, understood.
Can we have phi in both y1 and y2?
No, there is a phase difference of 5 means the difference between the phase is 5. So one should not have phase, right? 5. Here,
Oh,
for the first one phase is 0, second one phase is 5. So the phase difference will be 5. Understood?
yeah.
Okay. Now, what is cos minus theta? Cos minus theta is cos theta itself. Cos minus theta is cos theta. So instead of this, you can put cos theta itself. So I'm just going to rearrange 2a. Okay. Now listen. In the question, it was a sine function. The two waves in the question was sine function. So you'll write the answer in terms of sine function. Everything other than sine, you will put first. That means this cos you will put first. The sine you will write at the end. Okay, because it is a sine function. Anything other than sine will be the amplitude part. Okay, so 2a cos 5 by 2 sine kx minus omega t plus 5 by 2. I just rearranged. When you rearrange, anything other than sine, so this will be what? The amplitude. Understood what we did? So this is the expression for y. Take this down. Understood, King? Ishanvi understood, Ishanvi, what we did?
Yes.
Ishanvi, is it clear? Farsin,
Yes.
Yes, ma'am.
finish. Finish? Okay. Okay. Okay, so you're right. So this is the resultant wave, right? What is the direction of resultant wave? Positive x or negative x, Zian? What's the direction of this resultant wave? No direction. Minus omega t means it is positive direction, negative direction. Positive direction. Positive x means it is minus omega t. Okay, so in the question also both waves were in the positive direction. The resultant wave is also in the positive direction. Okay, and the phase of the resultant wave is pi by 2. What about the frequency? In the independent waves, omega is the frequency. Here also omega is the frequency. Frequency is the same. Frequency of the waves, initial waves and the resultant wave is the same. Okay, whereas wavelength of both waves are same. But phase and amplitude will be different. In the resultant wave, phase is different and amplitude is also different. Okay, so right. This represents, y represents the resultant equation. Y represents the resultant wave. The y represents the resultant wave. Y represents the resultant wave in positive x-axis direction. Y represents the resultant wave in positive x-axis direction. Y represents the resultant wave in positive x-axis direction. With the same frequency and wavelength. With the same frequency and wavelength. Y represents the resultant wave in positive x-axis direction with the same frequency and wavelength. Okay. But the initial phase becomes, but the phase becomes phi by 2. But the phase becomes phi by 2. The phase becomes phi by 2. Phase becomes phi by 2. And the amplitude is 2a cos phi by 2. And the amplitude is 2a cos phi by 2. And the amplitude is 2a cos phi by 2. Done, right? Clear. And now we'll see special cases. Completed? Completed, right? Now special cases. Write special cases. Special cases. See, listen. In special case, actually, what happens is there will be two conditions. One is you should remember these terms, okay? This year it's not that important, but next year, like one full chapter, wave optics, we will be studying this in detail. Constructive and destructive. Constructive means both same phase, like there is no phase difference. They will get added. I showed you. Two amplitude and 5 amplitude in the same direction gets added. You'll get 7. That is constructive interference. You call it as constructive interference. For getting constructive interference, the phase difference between the two waves should be 0. That means two sine waves will undergo constructive interference, right? What is the phase difference between two sine waves? 0. It's the same phase only. Two sine waves means they are in same phase. What about the phase difference between sine and cos? 90 degrees the phase difference, or what about the phase difference between these two waves? 180, right? When you see what is the phase difference? 180 degree. Then 180 degree ulta, right? 180 degree upside down. So these two waves phase difference is 180 degree. Okay, if the phase difference is 180 degree, what will be the resultant wave if amplitude is 0? Correct? Understood? Are you getting me? No. Understood. If they both are in same phase, that means this wave is 0, this is also 0 at the same time. At time 0, wave is 0. At this particular time, maximum. So they both are in phase. If two waves of same phase added, you will get the maximum. If two waves of opposite phase, that is like the phase difference 180 degree, if they added, you will get the minimum. So this type of interference, we call it as in the interaction between the waves is interference. So this interference, we call it as constructive interference. And this one, we call it as destructive interference. Now you just need to understand what it is. In detail, it is not there for you to learn. But you should know what is constructive and destructive interference. Okay, so that is a special case, okay? Write the special cases. This much is okay, right? Superposition. So just go through the equations. What do you mean by superposition principle? Superposition principle means if you have two waves, okay? Two independent waves. When they both interact, superposition will happen because waves obey superposition principle. What is superposition principle? Independent interaction of waves. So first wave is y1, you will write it as A sine kx minus omega t. And the second wave, A sine kx minus omega t plus 5. Why like that? Because the phase difference between these two waves is 5. Now when they added, what will happen? Sine A plus sine B. What is sine A plus sine B? 2 sine A plus B by 2 cos A minus B by 2. You will apply that formula here, you will get like this. Okay. Now cos minus theta, you will write it as cos theta. And you are just rearranging this resultant so that it becomes a function of sine. So sine term you will write separately. The remaining terms you will write together. The remaining terms other than sine will be the amplitude part. This will be the amplitude part. And this gives the displacement part. This is sine wave. This is the amplitude. Okay. So this will be the amplitude. Clear that much is okay? Now, in this, we will apply special cases. Give heading special case. First, when phi is equal to 0. When phi is equal to 0, what will happen? What is your y1? A sine kx minus omega t. What will be y2? What will be y2? What?
A sine
Kx minus omega t. Okay, what will be the resultant? 2a sine kx minus omega t. Correct, right? When you add, what will happen? Therefore, y will be 2a sine kx minus omega t. Understood? Just addition, right? A sin omega t plus A sin omega t, 2A sin omega t. That's it. Okay, so when phi is equal to 0, y1 and y2, and this will be the resultant. So what is the amplitude here? Amplitude
2A.
has become 2A. Phase is same. That is what I have shown you in diagram. You have a wave like this. You have another wave like this. What will be the resultant? The resultant will be addition of the amplitudes. Phase will remain the same. Understood? This is the diagrammatic reference. Understood, right? That concept. Okay, if this is happening, we call this as constructive interference. Clear? So, when phi is equal to 0, you wrote this. When phi is equal to 0, in bracket you write waves are in phase. Waves are in phase. There is no phase difference. Both waves are in phase. Waves are in phase. Finally, right? Here, resultant amplitude. Resultant amplitude A will be equal to 2A. Here resultant amplitude A will be equal to 2A. Here resultant amplitude A will be equal to 2A. This is known as constructive interference. 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 Done, right? Now second, for phi is equal to pi, for when phi is equal to pi, that's case 2, okay? Case 2, when phi is equal to pi, waves are out of phase. Waves are out of phase. We will get the, here we will get the, no need to write equation and all. Here we will get resultant displacement as 0. Here we will get resultant displacement as 0. The resultant displacement will be 0. This is the case. One is a positive and the negative. When you add, it will become 0. This resultant here, the resultant displacement is 0. And this is known as destructive interference. This is known as destructive interference. Understood? Clear, right? So that is constructive and destructive interference. Now next is reflection of waves. No, only 2 cases. Next topic is reflection of waves. Finished, right? All of you studied for oscillations test, right? You thought I forgot? Okay, right. Reflection of wave. Reflection of waves. We are doing reflection of waves. Reflection of waves. What happens? Huh? reflection of wave. Okay, I explained this point last class, remembering? A string, what? A string, when it is stretched like this, and you make you attach a rubber band here to you just tie a rubber band, you stretch it, you make a disturbance at this point, what will happen? The wave will go, it reaches here and it will reflect back. Actually, you will see the vibrations. Actually, that vibration starts from this end, it moves till the end and it comes back. That is actually happening. That phenomenon we call it as reflection of wave. Okay, there are two types of reflection. Only one is explained detail in textbook. That is reflection in a rigid boundary. This is a rigid boundary. Reflection in a rigid boundary is there. Reflection in an open boundary is there. Open boundary means the sound waves just getting reflected within the air particles. Open boundary. There is no rigid boundary. Okay, so rigid boundary, open boundary. Only rigid boundary you have to study in detail with the diagram. Okay, so reflection is nothing but the bouncing back of sound waves. That's it. Okay, so right. Reflection of waves in that first reflection at a rigid boundary. Reflection at a rigid boundary. Reflection at a rigid boundary. Done? So you're right. When a wave is reflected, when a wave is reflected, when a wave is reflected at a rigid boundary, when a wave is reflected at a rigid boundary, there will be a phase difference of pi . There will be a phase difference of pi between the incident and reflected waves. There will be a phase difference of pi between the incident and reflected waves. There will be a phase difference of pi between the incident and reflected waves. Pi. Pi, pi. 3.14 pi. That's it. And 180-degree pi. Okay, Snigdha.
Phase difference of
Pi. Phase difference of pi, okay. Pi radian. Phase difference pi between the incident and reflected waves. Okay. Now listen. There is a rigid boundary here, okay? This is a rigid boundary. So wave is traveling. Wave is traveling in this direction. Goes like this. It hit here, right? After that, it is getting reflected back. If it is reflected back, there's a phase difference of pi means goes like this, right? Understood? Cannot see. Reflect back like this. There's a phase difference of pi. Pi means like this. Just ulta will come. Phase difference of pi. Understood? Now, this is a positive going wave. What is the equation of this incident wave? What is the equation for incident wave? A sine kx minus omega t. What will be the equation for reflected wave? A sine kx plus omega t, because it's a negative going wave now. That will be the equations. Understood? Okay, so now you write the equation. If yi is a sin kx minus omega t, if yi, incident wave, if yi equals a sin kx minus omega t is the incident wave, if yi equals a sin kx minus omega t is the incident wave, then the reflected wave is given by yr equal to, then yr is equal to a sin kx plus omega t. Finished, right? Got it. Now you have to draw the diagram that you can take from the textbook. Those who are online, I will share. Huh? Your textbook, right? Reflection of who doesn't have. I only have it. You have? Huh? Past two. Okay. There is a reflection of a rigid wave diagrams. What?
Wave is,
What is?
the instant wave, then reflected wave is. Given by zero. So, right.
Second textbook, yeah. Last chapter. This is the last chapter, second book.
Page number?
I don't know. It is coming under the heading after superposition. After principle of superposition, I'll share, okay, for those who are online. After superposition, you have reflection of a pulse, 14.11, figure 14.11, 15.11, that figure.
From all that 5?
Yeah, all the
I
five.
draw this.
Yeah, you have to draw. Yeah. 1, 2, 3, 4, 5. This is what they are showing, the reflection. This is what they are showing. That is reflection. A wave is coming, it is hitting a rigid boundary, it is reflected back. If they ask reflection, you have to draw. Got the didn't get
15.1.
15.11 figure.
This one.
Yeah. Yeah, that one. What is your page number?
378. No, it is only 289. 289.
Finished. Okay. So reflection of rigid boundary is over, right? Now in your textbook only reflection through rigid boundary is given. Okay. See the equation also. On a rigid boundary, kx minus omega. You saw that, right? Now open boundary is also there. Just the equation is given. For open boundary, equation only is given. So I'm only giving the equation. Open boundary means the incident wave, same thing will get reflected back. There is no one phase difference is not there. If this wave is going, this wave itself will get reflected back. That is in case of open boundary. So incident and reflected equations will be the same. Understood? There is no diagram, that's why. Right. See, if this wave is incident, the same wave is getting reflected. That is the meaning.
No.
Okay.
Oh, it doesn't turn.
No, it doesn't turn. No need to draw the diagram. So right, second case, reflection in an open boundary. Just equation you learn. That's
In
it.
an open boundary, like if we are in an open place and then our voice
Yeah.
gets reflected like that.
Yes.
Is it like an echo source?
Echo. Is it reflection in open boundary?
Because like in big valleys, canyons, there's nothing to reflect on.
Echo, there is some other phenomena behind that.
I don't know. But then echo it comes multiple times. What's the point? How other?
Yeah, anyway. Nothing else is there given. I'll check. Okay. Reflection in an open boundary. Reflection in an open boundary. For reflection in an open boundary, there is no phase difference between. For reflection in an open boundary, there is no phase difference between incident wave and reflected wave. For reflection in an open boundary, there is no phase difference between incident and reflected wave. So yi is given by a sine kx minus omega t, and yr, the reflected will be also given by a sine kx minus omega t. That's it. Write the equations. There is no phase difference between incident and reflected wave. In open boundary, there is no phase difference between incident and the reflected wave. So yi and yr will be the same. That's right. Okay.
Echo is closed boundary. Echo is closed boundary.
Closed boundary, not open boundary. And that's right. Okay, next give heading. Standing wave and normal modes. Yeah. Equation I will check, okay, for this one. Reflection in an open mode. Anyway, in textbook only equations is given. Okay. Next is standing wave and normal modes. So standing wave part I will teach you later. Like you will write two equations, you will add. That's it. That is standing wave. What is the standing wave means? The same as what we studied, the wave equation. In understanding wave, we will study. Okay, then the next is modes. Normal modes. Normal modes means in 9th grade you study two terms. Node, antinode. Remembering studying? In 9th grade, what is a node and an antinode? Heard of these terms? Nodes. The distance between two nodes or distance between two antinodes is wavelength. What is node and antinode? Which one is what? The position with maximum amplitude is antinode. Okay, so if this is a wave, these maximum points we call it as antinode. Okay, the points at which the amplitude is 0 is node, and the point at which the maximum amplitude is antinode. Okay, so just write node and antinode. Just write two definitions, okay? Node and antinode.
Amplitude 0 means the line.
In between the waves, the amplitude 0.
Node is what?
This is node.
So it's the straight line.
This is a wave, right?
Ah.
In the waves, if the amplitude becomes 0, the points at which the amplitude of wave becomes 0. Sine 0 is 0, right?
What about
0. Not minimum. The point at which the amplitude becomes 0 is a node.
does that have a name? The minimum amplitude.
Minimum amplitude is 0 only, right?
It's not going down.
If it goes down also, that is a negative peak, we say. The maximum displacement in the negative direction. That is how we will say. Okay. Okay, node definition you write. Okay, node and antinode. Yeah. Right. Node. The positions of 0 amplitude is called as node. Node. The position of 0 amplitude is known as node. Position of maximum amplitude is called as antinode. Position of 0 amplitude is node. Position of maximum amplitude is antinode. Finished, right? So I'm not we will do few problems on the previous topic. I'm not starting this topic in detail. Okay, under this topic, what is coming is actually in a stretched string. In a stretched string, if vibration happens, how many notes, how many antinodes, based on that, you will study about fundamental frequency, first harmonic frequency, few terms are there. On a stretched string, you will study. Okay, then you will study for a closed tube. Closed tube means, have you, anybody did tuning fork experiment in school? Tuning fork experiment? Tuning fork experiment, the teacher showed you in 9th grade? Okay.
No, ma'am.
In physics lab, did you see a long tube column? A long tube is placed. And have you seen tuning fork?
Yeah, it's like this.
It's like this, a fork of this type. And there is a long tube column in your, it is filled with air. Air only, the normal tube only. Okay. And when you strike this tuning fork near to that, you will be hearing the sound.
On the other side. On the other side.
And you will measure an experiment. You can check the experiment. So that is an open tube. What we just need to know what is an open tube. Open tube means one end closed, the other end open tube. Okay. In that open tube, what will be the shape of a wave? And what will be the fundamental frequency, first harmonic, second harmonic frequency, like that. Then open tube. Open tube means both ends open. One end open is closed tube. Both ends open is open tube. 3 cases. In a stretched string, what are the how is the waves formed? Then in an open tube and in a closed tube, how the waves are formed. You can see in the textbook, in the next pages, you will see some interesting diagrams which you will be drawing next class. See, 13, I'm talking about figure 13, 14 and 15. So that is what we will be studying. Based on the number of nodes and antinodes, we will be studying those diagrams. Okay. Then after that, beats. Beats is the last topic. Beats is the last topic. And next class, we can finish this chapter. Okay. So now we will do few problems from the previous topic. So notes, if I start, I mean standing waves, if I start, you have to finish that topic. So I'll start it next class. We will do problems, right? So one small topic only. Like all are similar. Like if you first thing, understanding the first thing is difficult, then the next remaining is related to that only. So we'll do a few problems. Okay. Write the question. Two waves of equal frequencies. Two waves of equal frequencies have their amplitudes in the ratio 3:5. Two waves of equal frequencies have their amplitude in the ratio 3:5. Have their amplitude in the ratio 3:5. They are superimposed on each other. They are superimposed on each other. They are superimposed on each other. Calculate the ratio of I max to I min. I will explain what it is. I max means intensity. So for doing this, you should know I max is intensity maximum, I min is intensity minimum. For doing this, you should know one formula. Intensity is equal to amplitude square. You should know this formula. Intensity and amplitude relation. So you know the ratio of amplitude, you can find the ratio of intensities, right? Correct. Do. So for finding maximum amplitude, the formula will be I max will be A1 plus A2 the whole square, and I min will be A1 minus A2 the whole square. So A1 and A2 are these two. Okay. For finding maximum amplitude, you will get maximum intensity, you will add this and square. For minimum intensity, you will add this and. Or do one thing, change the question. Instead of I max and I min, you write I1 and I2. That is enough. Find the ratio I1 and I2. Do that. So what will be that? For doing that, you know, A1 by A2, amplitude ratio. A1 by A2 is 3 by 5. So what will be I1 by I2? Root of that, right? Intensity is equal to amplitude square. Amplitude square. So square of that, right? Yeah. So I1, therefore I1 by I2 will be equal to 3 square by 5 square. That is enough. 9 by 25. You just need to remember this formula. Intensity is equal to amplitude square. Now maximum and minimum, you cut that question, okay? Write the next question. The displacement of a wave is given by. The displacement of a wave is given by. 3 sine omega t. Three sine omega t plus 4 cos omega t. Displacement of a wave is given by 3 sine omega t plus 4 cos omega t. Find the resultant amplitude. Find the resultant amplitude. I'll give you the formula to do. So, if you have like this, y1 sine omega t plus y2 cos omega t. So the formula will be root of 3 square plus 4 square. That will be the answer. Okay, they are asking the resultant amplitude, right? So for finding resultant amplitude, what will be cos square theta plus sin square theta will be what? 1. When you square and add, it is basically root of y1 square plus y2 square only. Okay, when you do, what you will get? 3 square sin square omega t plus 4 square cos square omega t. Okay, sin square theta plus cos square theta will be 1, so you will get 3 square plus 4 square only. So it will be how much? 225, right? Fine. Understood. These are exemplar questions, so they can ask. In the question, it was no, yeah, it was given in centimeter. Okay, in the question, it was given centimeter. So 5 centimeter. Okay, finished, right? So next class we will do. So Laplace correction very important. You marked it as important. Now, whatever we are studying next class is also important from this chapter. Laplace correction and next class topic is most important from this chapter. Okay, so next class we will finish. Then from the next week we will be studying. So revise oscillations and waves. Okay, whatever we studied. After finishing waves, I will ask you questions. Okay, so Who all got portions for your next exam? Next exam in the sense,
Exam